In this knowledge-based video, I want to demonstrate a utility that Fred has that I think a lot of people miss, called the single ray trace. If I have a model like this here, this is just a cooked triplet that I've imported, in this case from a code 5 sequence file. One of the first things I very often want to do is just verify that the prescription came in correctly. Make sure that these lenses are in the right positions, make sure that when I perform a ray trace, I get the same results in terms of ray intercept positions, angles of incidence, ray direction vectors that I get in Fred compared to something like Code 5 or Zmax. And the single ray trace feature is a good way to run that comparison very quickly. So if I come up to the ray trace menu, you'll see an option here called Trace Single Ray. We get this dialog that I'm going to leave over here. The idea is that I am going to trace just one specific ray in through my system. The single ray can come from any of the three sources indicated here by these toggle buttons at the top of the dialog. So I can define a custom ray. I might come down here and say the starting point is -1. I can define this position vector in any arbitrary coordinate system that I want. Maybe I want this position vector with respect to the first surface of the triplet. The ray direction vector can be specified either as an ending point, and the starting point and the ending point therefore define a direction vector, or I can just specify the direction vector directly here. In this case, it'll be the direction vector will just be along the z-axis. And again, you can choose any coordinate system that you want. I'll choose surface 1 of the triplet. Continuing on with my single ray customization, I might choose activate some polarization, coherence properties. I can set a unique wavelength, set a starting immersion material. So that defines the custom ray that I'm about to trace through my system. Now, the bottom half of this dialog allows you to tell Fred what information you're interested in reporting to the output window. And what will happen, as I'll show you in just a second, is for every surface intersection along the ray's path through the system, Fred will report whatever information you activate here. So maybe I want to see the XYZ position vector of each intersection. Maybe I want to see the ray's direction vector of each intersection. Those are useful quantities when comparing single ray trace data between Fred and your design program. Might also want to see angle of incidence or the ray's immersion material in any particular optical space. So you're going to toggle the various quantities that you want to see for each ray intersection. I'm also going to toggle this option here that says suppress the ray trace summary. I do want to draw the ray in the 3D view, so I'll turn on the plot option. And I'm going to go ahead and pick a ray color red so that I can see that ray drawn clearly in my 3D view. One last thing you get to choose here is this data, particularly these vectors here, are going to be expressed in a particular coordinate system, and you get to choose what coordinate system that is. Maybe it's for a particular surface. Maybe you want to see the data expressed in the local coordinate system of each intersection. That would be the self option. We can just use the global coordinates for this demonstration. That's fine. Now, the thing you want to do here with this dialog is hit the apply button. If you hit OK, the single ray trace is going to execute. This dialog will go away. It'll disappear. If you reopen it, you'll have to reconfigure all these settings. So until you're really done with the single ray trace, go ahead and leave it open, and then we'll just hit apply. So here we've traced the gut ray through our triplet. The output window, now we can see the results of that single ray trace. We have the ray's position vector, the ray's direction vector, and an angle of incidence for each intersection here as the ray propagated through my system. So here I can see, we'll just randomly choose this intersection with surface 6, which will be this surface here of the third element of the triplet. We can see that the global position of that intersection was 23.294. In this case, it's millimeters. It's the gut ray, so the direction vector was still along the z-axis, and the immersion material was LAKN 22. So that's for a custom ray of your definition. You also have a couple of other radio buttons here that are useful. In this case, you can see I've got 3 field positions defined, 3 sources. And I might want to toggle this radio button here. And given the rays that are already defined by this particular source nodes, I might just choose a particular ray number out of that source. Now, this is useful when you know specifically what the source construction is. Otherwise, you have no idea what the ray number corresponds to. But for any given ray number, you can see that Fred is printing a summary of that ray information that you're about to trace. So that's the starting information for the single ray that's going to be traced. We can just hit apply using the same settings. You can see now we've got an off-axis field point, and we have the XYZ intercept, the ABC direction cosine vector for each intersection, angle of incidence, and the immersion material. So this information here is really valuable, again, primarily as a debugging tool in Fred, I find, for validating systems that you've imported, confirming spacings of elements. You can do inter-element spacing if you toggle this previous distance here, and then trace that gut ray. That will tell you what the optic-to-optic spacing is as that ray propagates through the system. So I hope this tool is useful to you, and please submit any questions you have about this tool to fredsupport@photonengr.com. Thanks.